Number 27, we are given r of x equals the log base 1/2 of x minus 3. And we are asked to sketch a graph of this function. So this is where I'm going to start by creating my little table using the log base 1/2 of x as my base function. And I'm going to plug in the -1, the 0, and the 1 in place of the y values, and then figure out what x values go along with it. Because this is where, in order to figure out what goes in this column, this is where I'm saying the log base 1/2 of x is equal to -1. So what is the x value that makes that statement true? So if I rewrite this as an exponential equation, this is the same as saying 1/2 to the -1 is equal to x. And then 1/2 to the -1, that's just telling me to take the reciprocal, which gives me a 2. So all of that is telling me that when x is equal to 2, the log base 1/2 of 2 is -1. And then same with 0. Since this is the y value, this is the same as evaluating 1/2 to the 0, which is just 1. And when y is equal to 1, that's the same as evaluating 1/2 to the first power, which is just 1/2. So I'm going to start by plotting that collection of points. So we've got 2, -1, 1, 0, and 1/2, 1. So just the graph of log base 1/2 of x would look something like that. So now I'm going to take care of my transformation. We see that -3 after the x, and the fact that it's on the inside of the parentheses with the x tells us that it's going to affect our graph horizontally. And specifically, since it's a negative, that's when our graph moves to the right. So we're going to take all 3 of these points that we've already plotted and shift them to the right 3. So this point, right 1, 2, 3, would end up at 3.5, 1. 1, 2, 3 would put this point at 4, 0. And 1, 2, 3 would put this point at 5, -1. And then we connect those to end up with a final graph that looks something like that. Number 28, we are asked to graph the function p of x equals 3 minus the log base 2 of x plus 1. So the first thing I'm going to do is just flip this around. I'm going to rewrite it as negative log base 2 of x plus 1, and then put this positive 3 on the end, just so the function is written in the form that I'm used to seeing it in, and then I can take care of my transformations from the left to the right once I get to that point. But I'm going to start by creating my table for the base function log base 2 of x. And again, I'm going to plug in my y values of -1, 0, and 1, because in order to figure out what is the x value that makes the log base 2 of x equal to -1, I rewrite this as an exponential equation, which would look like 2 to the -1 is equal to x, and then 2 to the -1, that tells me to put the 2 in the denominator to get 1/2. So that's telling me that the x value that corresponds to a y value of -1 is 1/2. And then the same with these other two. When y is equal to 0, that's the same as evaluating 2 to the 0, which is 1. And when y is equal to 1, that's the same as evaluating 2 to the first, which is 2. So I'm going to start by plotting those 3 points. So we had 1/2, -1, 1, 0, and 2, 1. So here's what the graph of log base 2 of x would look like. And then the different transformations. So starting with the negative in front, that tells us to flip all of our points over the x-axis. So that's going to take this point from a y-coordinate of -1 to a y-coordinate of +1. A point on the x-axis is going to stay on the x-axis, and a point that has a y-coordinate of +1 is going to go to -1. So this would be the graph of negative log base 2 of x. And then the other transformations that we need to take care of here are the +1 inside the parentheses and then the +3 on the end. So since the 1 is inside the parentheses, that tells us to move to the left 1, and then the +3, since that's outside the parentheses, tells us to move up 3. So I'm going to take all of my points from the pink graph and shift them left 1, up 3. So left 1, up 1, 2, 3 would put my first point at -1/2, 4. Left 1, up 1, 2, 3 would put my y-intercept at 0, 3. And left 1, up 1, 2, 3 would put my third point at 1, 2. And then we connect those to get a final graph that looks like that.